So this is going to be our first official lecture. I'm going to go ahead and just deliver this entire section. I'm going to do my best to honor the time, but I'm probably going to stop and prepare for the next course once I finish this section. So let me see how many. We don't have too terribly many. Give me a moment. There we go. Oh no, we don't need all that. All right, come on. I need you to like go here, out of the way. I need you out of the way. I just need you to be like here. There we go. Boom. Okay. So, all right. My signal strength looks good. All right. So what we're going to do, and I got my pen. I think I'm good to go. So we're going to go ahead and do this first section, and then we'll call it a day. Oh, I don't know if anybody, oh, you can't see it here. Darn, that sucks. The time is about to hit 11:11, but you can't see it because when I plug it in, I don't know, the time shows weird, but it doesn't matter. But the time is now just about at 11:11. Anyway, it doesn't mean anything. So, I mean, like I said, let the image stay for now. So we're going to go ahead and do this first section. This is chapter 1, real numbers. This is support for college algebra, okay? So yeah, again, I'm available for questions. So now some things that we need to be aware of. We need to figure out how to get access to online. So that's Collaborate and my YouTube channel. Probably my YouTube channel is better because this is what I'm used to. We need to go ahead and get registered for Pearson, okay? So we'll be in contact about that and getting that set up and make sure you have access. And just kind of start submitting our materials. We're going to have a quiz this week. You can expect a quiz or an exam every week. You can go ahead and go ahead and get ready for exam 1 next Friday. Okay, it'll be on Pearson. Okay, but you don't want to just do the exam because you're not going to have any support. You're going to have minimal support with that. But these other things with the quizzes and the homework, you get all this feedback. So we're going to actually start off with section 1.3, fractions. Okay, I think I could just go like this. Is it going to work? No. Let me see. I think I could do it here. All right, that's fine. So some of the objectives here. What color am I feeling? I don't want to do red. I'm going to close my eyes, and I'm going to choose like this size. I'm going to try to choose a color at random. Boop. What color did I get? Nothing. Okay, I got green. That's fine. So if you're any of my former students, you know what this is. And let's go like this. I'm just going to use this to kind of draw your attention as my cursor. Okay. Actually, let me just do this real quick. Boom, just like that. Okay. So some of the objectives here: learn the multiplication symbols and recognize factors. Okay. Understand prime numbers and the greatest common factor. Number 3, simplify fractions. Number 4, multiply fractions. Number 5, divide fractions. 6, add and subtract fractions. 7, change mixed numbers to fractions and vice versa. Okay, give me just a moment. I'm going to do something here. All right, so let's keep going. So let's see. What do we mean by what do we mean by multiplication symbols? Can I do like this? That's fine. That's about the same. Is there a? Let me try this. See really quickly. What does it look like? I don't get what that does, so I'm not going to worry about that. Can I turn it off? Okay. All right. So a multiplication symbol. It says if A and B represent any two. If A and B represent any two mathematical quantities, then each of the following may be used to indicate the product of A and B. So when we multiply numbers, right? So let me copy that image. Yeah, let's just copy this guy. So, okay. if A and B represents two mathematical quantities, then all of these following forms represent A times B. So what do we mean by multiplication? So these are some of the ways that we represent multiplication. The first we have here is this A times B. So this guy here, it'll look like this. All right. This one is A dot B. This one is A parenthesis, open parentheses, B close parentheses. This is also A in parentheses times B. And this is, all of these just basically mean A times B. So these are some of the ways that we show multiplication in mathematics. So for instance, if we said 3 times x may be written in any of these all mean the exact same thing. 3 times x, 3 times x, 3 times x, 3 times x, okay? These all mean the same thing. So what are factors? The numbers or variables that are multiplied in the multiplication problem are called factors. If A times B equals C, then A and B are factors of C. So factors are things that we multiply. Factors are things that we multiply. Okay? I'm just going to let that be for now. So let's look at some more definitions. So what do we mean by natural or counting numbers? Natural numbers are numbers like 1, 2, 3, 4, 5. Okay. This is the first extra credit question, Easter egg, okay? So if we look at this natural, so if you're one of my students in this, I'll make it open to any of my classes, right? Because I don't expect my other students to watch this if they're not in the class. But if you're in any of my classes at the moment, you first, I don't want this open to everybody. If anybody gives me this Easter egg before the next lecture, then I'll consider extra credit for it. Okay, so if you're watching this and you see this Easter egg and you answer it correctly, but you only have until, so if today is what, Wednesday, you only have until this Friday to get this Easter egg. Beyond this Friday, I'm not going to consider extra credit for this question. Oh, side note. So the way I do extra credit, I do a point-based system. You can earn a maximum of 100 points extra credit. At the end of the quarter, what I'm going to do is scale that to 10% of your grade. So like if you somehow are able to max out your extra credit, then your grade could potentially be boosted by 10%. Say you finished at a 66 and you max out your extra credit, you could potentially finish at a 76. The thing with extra credit though is I'll only apply it at the end if I can. Sometimes at the end I couldn't apply the extra credit because it gave everybody an A, and obviously I can't do that. But if I can apply it, I will. The extra credit kind of serves as, it's kind of like, it's better to have it and not need it than need it and not have it, right? So this extra credit opportunity is, the question here is, you see these numbers 1, 2, 3, 4, 5, and so on. How many numbers are listed in that set of natural numbers, which you see on the screen right now? So for this set right here, how many numbers are showing? How many numbers are in this set? Okay, that's my question. Okay, so if you correctly answer that before this upcoming Friday, I'll consider extra credit for it. As you accumulate extra credit, you definitely want to have a log of it. I'm going to be logging it on my end, but you definitely want to have a record of every time you know that you've gotten extra credit. Okay, so I'm going to let that be. A prime number is a natural number excluding 1 that can be divided by only 1 in itself. Yeah, so prime numbers, the only factors are 1 in itself. It doesn't have any other factors. Prime factorization is basically where we take a number and we want to break it down to all of its prime numbers, a product of prime numbers, okay? And then the greatest common factor of two natural numbers is going to be the greatest integer that is the factor of both numbers, okay? So we'll see all these in action. We'll see all these in action. I did just make these notes. I'll make these notes available on Moodle, but I did just load them in our box folder. Okay, so to access box, you go to our Moodle page and you click on the box link, go to the notes, and you'll see something inside folder number 2 that says notes. You'll see something that says PowerPoint lecture slides. But now, anything that you see me writing, I'm going to save a copy of this for you as well. I'm going to save it in that same folder, and you'll be able to access all this information as well. So how to find the greatest common factor of a given numerator and denominator? Write both the numerator and the denominator as a product of primes. Determine all the prime factors that are in common to both prime factorizations, and then multiply the prime factors found in step 2 in order to obtain the GCF. So we want to find all the prime factors that are common to both, and then multiply those, and that's how we find our GCF. We're going to see this in an example. Okay. So this one at the bottom of the screen, actually what I'm going to do, I'm going to get a copy of this because I don't want to show the answer. Again, if we start with the answer, we're going to be building bad habits and we're not going to be prepared for the exam. But in preparation for the exam, all we're going to do is take the question. We don't want any support until we've kind of exhausted our train of thought. So I'm going to go like this. And I'm going to take this guy. What's the time? I'm watching the clock. I just want this, right? And then I want to just add a page right there. And I just want to drop you in there. Boom. And I want you, come on. Yeah, come on. Yeah, I want you right here. Just like that. Ooh. And let's crop. All right. And I'm going to do one other thing. I'm going to put on graph paper. Oh, so this app that I'm using, this is Notability. This is an app called Notability. I think we're okay there. And I'm just going to go to black for right now. Okay. So we're actually determining the greatest common factor of 108 and 156. So the instructions that we just got said to write the prime factorization of each number and then ask yourself what prime factors do they have in common, and then multiply those common factors, and that's our GCF. So let's start with the prime factorization of 108. Okay, so I'll do 108 in this color. We'll say 108. That's not an O. 108. Right. So then we ask ourselves, what times what is 108? Well, because it ends in 8, I know it's at least divisible by 2. So I'm going to say 2 times what? 54. Right? Because I said 10 divided by 2 is 5. 8 divided by 2 is 4. Right? But then I see the 54 is also divisible by 2. So then the 54, I'm just going to bring this 2 down. 54, I know is 2 times something else. 5 divided by 2 is 2. 14 is 7. Right? So 54 is 2 times 27. So now I know that 27 is not divisible by 2, but now what times what is 27? What, 9 and 3, right? So 27, I know that 27 is the following. 27 is 3 times 3 times 3, right? 9 times 3. This 2 just comes down. This 2 comes down, and this 2 comes down. So 2 times 2. So then long story short, 108 is 2 times 2 times 3 times 3 times 3. Let's go back and do the 156. So we're going to do 156. We do the same thing. What times what is 156? Oh, I see the 156 ends in a 2. Ends in an even number, so it's at least divisible by 2. So then 15 divided by 2 is what? 7. And you got a remainder of 1, so that becomes a 16, and that's an 8. But then I see that 78 is going to be 2 times something. There are 3, and then 18 is a 9. And then 39 is what? 3 and 13? So then 3 times 13. I think these are all the prime factors. Okay. So then our claim is that 156 is 2 times 2 times 3 times 13. Now, I'm open to the following. This is Easter egg number 2 for today. So I'm not going to exclusively go through and be meticulous about my work. Sometimes I'm intentionally going to make mistakes. Sometimes I'm not. I'm going to just kind of keep moving with it. So now, if I make a mistake during any of these presentations, this is open to all of my students. If I make a mistake and you catch it and you correct me, the first person, let's go ahead and for right now, because it's so early, I'll give you until the next class time. I want to give you some time. I want to make it open to people that want credit. So if I make a mistake, if you bring it to my attention, if I walk away from a question and I finish out the presentation and it's wrong, if you correct it or bring it to my attention, I'll offer extra credit for that. Okay? My job is to be accurate and consistent and precise in all of this. Your job is to keep me honest. I'm a spiritual being having a human experience like everybody else, which means is that I'm allowed to make mistakes too. I definitely make them. So if you catch a mistake of mine and you correct it and bring it to my attention, I'll offer extra credit for that. Okay? We got about 25 minutes remaining, so I'm going to keep pressing forward in this presentation. So then the instruction said to basically take these, and find let me copy, find the factors that are common to both of them, right? Copy and paste. So again, this first one, well, that one was what? We could just copy and paste. Okay, this was here. This was this one. That was this style. And it's this one. Okay. So 108, and let's add a page. So 108 is 2 times 2 times 3 times 3 times 3. 156 is 2 times 2 times 3 times 13. Okay, these are all prime numbers. All of these numbers, these are the prime factors of each of these larger numbers. Each of these prime factors, the only numbers that they're divisible by are 1 in itself. Okay, so then to find the GCF, now if we mix blue and green, green is what? Blue and yellow. So since the only one that's missing is yellow, I typically don't do yellow because it doesn't show up properly. So the greatest common factor, what we're going to do, basically, let's go here, this. Let's go to style, the fill, we need it to be that same color. That's fine. Copy. Okay. So we want to take ones that are in common, right? So they both have at least 1, 2. They both have a second 2. They both have this 3, and then that's all they have in common, right? They don't both. That's what they have, right? So then if I paste, so they both have a 2 right there, and they both have 2 2s and 1 3. So then the GCF, 2 times 2 is 4 times 3 is 12. So the greatest common factor of these two should be 12. Okay. Let's try another one. Let's go. Let me get rid of this. I don't need that. And I'll let that stay. Okay. So we got 12 going forward. Let's see. How do we do? See, they both had 2 2s and a 3. So the greatest common factor is 12. Awesome. We got the same thing. Yay. Okay. You got to celebrate whenever you get a chance. It's so many things out here that just intentionally like keep us down and keep us deaf, dumb. They want us to be deaf, dumb, stupid, confused, intimidated. They don't want us to do this stuff. So they do whatever they can to deter us, but because they know that at the end of the road of education is freedom, and they don't want us to be free, they want us to be slaves. This is what made me fall in love with mathematics. So this is a discussion about freedom. This is like modern day slavery, but we at least have a chance to create a life that we want more so than our ancestors. You know what I mean? And this is not just for like, it's just not to be like pro or anti anybody. It's just what it is. You can't deny this notion. But when I say they, I'm just talking about the powers that be, not anybody in particular. It's just whoever's in power that's trying to keep people down. That's neither here nor there. So let's look at simplifying fractions. Let me see the clock. I'll go for about another 10 minutes or so. We can probably make it. So a fraction is a fraction is simplified or reduced when the numerator and the denominator have no common factors other than 1. So to simplify a function, determine the GCF of the numerator and the denominator, then divide both the numerator and the denominator by the GCF. Okay, let's see this in action. So we're asked to simplify. So let me get a copy of this. So I don't need that. I can cut that out. Let's go like this. And let's go. That's fine. We're going to take this and drop you right here. And we're going to add a page here. Boom, just like that. Come on. There it is. All right, so let's look at this example. Example 3. So we're asked to simplify this. So we're just going to go back to black. The suggestion was to find the GCF, write the numerator and the denominator, find the GCF of the numerator and the denominator, and then divide both the numerator and the denominator by that GCF, okay? So first we need to write these in the prime factor form. So we have 10 divided by 25. Now 10 is what? 2 times 5. 25 is 5 times 5. So what factors do they have in common? So in this case, the greatest common factor is 5. So then basically what we're going to do, we're going to take our fraction, and then we're going to say, I think it goes like this. We're going to say the top divided by 5 and the bottom. We're going to divide both of those by 5. Okay? 10 divided by 5 is 2. 25 divided by 5 is 5. And that's our final answer. Okay, let's see how do we do. So we're asked to simplify. It says the GCF of 10 and 25 is 5. Divide both by 5 and we get our answer. We had a couple of other examples, but you see them there. For the sake of time, I'm going to leave the rest of these as exercises, okay? So multiplying fractions. To multiply two or more fractions, multiply the top with the top and the bottom with the bottom. That's the long and short of that, okay? So we're asked to multiply this. So let's get a copy and let's simulate the testing environment. We're not going to look at the answer just yet because we're not going to be able to look at the answer on the exam. So we want to try to see, can we get to the answer on our own first? So let's add a page right here. Okay. Boom, just like that. Okay, that's fine. So we're asked to multiply here. So they're asking us to do 3 over 13 times 5 divided by 11, right? So notice, neither of these fractions can be simplified or reduced any further. So to multiply fractions, you say the top times the top, bottom times the bottom. So all we're going to do is say 3 times 15 divided by 13 times 11. Let's see, 3 times 15 is 30 plus 15 is 45. 13 times 11 is 110 plus 33 is 143. And because nothing canceled, this should be our lowest terms. 15 over 143, awesome sauce. Yay! Okay. Again, you want to celebrate, trying to break up the energy, not make it so boring. You know, hopefully we're all aboard and we're not all bored, you know, once we get access to this. Okay, let's keep it going. Let's look at this example. I don't want to see the answer though. Okay. And actually, I'm just going to do the same thing. I'm going to get a copy so we can simulate the testing environment. So I just want just the question. Okay. I don't really want to look at the answer and see, can I arrive to the answer on my own first? Because we're not going to have the answers when we get on the exam. So if we always go, whatever we practice, that's what we'll get good at. If we practice making excuses, that's what we're good at. If we practice just looking at the answer and working backwards, that's what we're good at. But keep in mind, on the exam, you're not going to be able to work backwards. You see what I'm saying? So this is why we do it this way. Anyway, so this example says, it's about fruit punch. Jennifer runs a catering business and needs to make fruit punch for a children's party. A recipe for making 1 gallon of fruit punch calls for 3 out of 32 of a gallon of frozen concentrated orange juice. How much frozen concentrated orange juice would Jennifer need to make 6 gallons of the fruit punch? Okay, let me think about this. So 1 gallon equates to, let me see, for making 1 gallon of fruit punch calls for 3 out of 32, 330 seconds of a gallon of frozen concentrated orange juice. How much frozen orange juice would Jennifer need to make 6 gallons? Okay, so the way I'm going to do this the way we do conversions, right? I think that'll work. So now, if we want to finish with what? 6 gallons. She wants 6 gallons. All right, I'm going to do it like this. I'm going to put this over 1. So now when we do conversions, we do times, right? Now, what does it say? It says that 1 gallon, so since we have gallons on top, when we do our conversions, when we do the next fraction, that means gallons need to be on bottom. So 1 gallon corresponds to 3 out of 32. I'm just going to put FZ for the frozen concentrated. Okay. So then it says how much frozen concentrated will she need for the 6 gallons? So when we do conversions, since we have gallons on top, we did gallons on bottom. Now the units of gallons cancel. And we're going to finish in the units that we need, in the proper units, right? So then long story short, all we need to do is say 6 times 3 over 32, right? And that'll give us the frozen concentrated whatever that we need. Okay. So let's do this over here. 6 times 3 over 32. To multiply fractions, we multiply top with the top, bottom with the bottom. Okay. So this 6 can be rewritten as 6 over 1 times 3 over 32. What's my time? I want to go for about no more than 10 minutes, really right at 5 minutes. Okay. Let's write the top and the bottom in prime factorization form. Now 6 is 2 times 3, and we're going to bring down that other 3 they already have. 32, I know is what? 2 times 16, but 16 is 2 times 8, but then 8 is 2 times 4, but then 4 is 2 times 2. All right, that takes practice what I just did. Now, I'm going to cancel my like factors. We can cancel factors. As long as it's all multiplication and division, we can cancel. If it's not all multiplication and division, then we can't cancel, right? But since this is all multiplication and division, we can cancel like this, right? No, there are no other common factors to cancel, so now we just multiply back. So on the top, we get 9. On the bottom, what is that? 4 times 4, we get 16. Frozen, whatever the units are. It says, how much frozen concentrated orange juice? 9/16 of a gallon. 9/16 of a gallon of the frozen concentrated. All right. Those are the units. Let's see, how do we do? Watching the clock, we're kind of there. Let's see, 9 over 16. So she was need 9/16 of a gallon of frozen concentrated orange juice to make 6 gallons of fruit punch. Okay. Let's move along. Dividing fractions. So in order to divide one fraction by another, multiply the reciprocal of the divisor, the second fraction. Okay, long story short, to divide fractions, we're going to use a technique called keep, change, flip. Let me see. I'm pretty sure that's gone, so I'm going to choose a different color. Something like this is fine. And let me fill it in. I'll fill it in like this. I'm just being meticulous. I'm just going to be a little bit silly and kind of get rid of a few little bit. That's fine. Let me just do it like this again. I think that'll work. And then just do like this style. I'm gonna thicken it up. That's too thick. That'll work. I don't like this. It don't matter. Actually, let me undo. I know we're pressed for time. I'm just being a little bit silly. I want to delete this. Yes. I can delete that one. Which one is better? It's honestly a little bit better. That's fine. I'm just being a little bit silly. All right, anyway. So let's go like this. Lost my train of thought. Let's see. Oh, so when we say one fraction, let's copy this. When we say one fraction divided by another, so one fraction divided by another, I got like 5 minutes. One fraction divided by another, we keep the first one, change division to multiplication, and flip the second one, okay? So I got a couple more slides. Let me see if I can finish this out. So for the sake of time, I'm gonna just kind of breeze through these a little bit quick. So if we said one fraction divided by another, we keep this, change division to multiplication, and flip the second one. And then from this point, you know what to do. 3 times 3, 6 times 3, and 5 times 5, we get our answer. Again, keep, change, flip, we get this. Top times the top, bottom times the bottom. And we get this, okay? So I'm going to have to let that be for now because we are kind of out of time. Now, to add and subtract fractions, first we have to get a common denominator. So to add and subtract fractions of the same denominator, we just add the top with the top, bottom Sorry. To add fractions that have the same denominator, just say the top plus the top. That's it. To subtract fractions of the same denominator, we say the top minus the top. Okay? I'm going to have to leave these as an exercise for you because we're out of time. So in order to add and subtract fractions, we have to use a least common denominator or least common multiple of our denominators. Okay? So you're gonna have to read this on your own. And then, for example, here, if we want to add these two fractions, let me just kind of do it. Let me just do it so you can see it. I think that's the simplest way. But we are just about out of time. Okay. So I'm going like this, and I want to add a page right here. Okay, let me just do this one really quickly. Okay. So now, if we want to do 1 over 6 plus 7 over 15, common denominator, so the least common multiple. So to get the least common multiple, when it's all numbers like this, I do the following thing. I take the largest denominator. In this case, the largest denominator is 15. So I ask myself, is 15 a multiple of 6? And the answer here is no. So then what I'm going to do is say 15 times 2, we get 30. Is 30 a multiple of 6? Yes. Is 30 a multiple of 15? Yes. So the least common denominator, which is the same as the least common multiple of the denominators, in this case, come on, is going to be 30. Okay, I'm watching the clock. I got a couple of minutes, about to wrap it up. So we want to get both of those denominators to be 30. So this first one, we have to we're going to multiply by 1. 1 times anything is itself. So we're going to multiply by 1 in the form of 5 over 5. This other one, we're going to multiply by 1 in the form of 2 over 2. Okay? So then we get 5 over 30 plus 14 over 30. Now we just add the tops and we get 19 over 30. Okay? Let's see, how do we do? 19 over 30 is good. So this example, we're almost there. Says how much larger is 3 over 4 than 2/3? So we're subtracting fractions. Again, we get a common denominator. Okay. 4 and 3, the least common multiple between 4 and 3 is 12. So notice in both of those fractions, we're multiplying by 1 in the appropriate form. Okay. I'm going to have to leave that as an exercise. And to convert this to a fraction, let me see, do I still have it ready to go? Awesome. So to convert this to a fraction, what we do, okay, so look, 7 and 3/8 is the same as 7 plus 3 over 8, right? So if you get a common denominator of 8, the 7 turns into 56 divided by 8. 56 plus 3 is 59, and we're done, okay? I like that. I was about to do something different, but this actually works, okay? I'm going to have to leave this as an exercise, okay? So what I'm going to do, I'm going to go ahead and I'm going to hit share, and I'm going to send this to Box. And our location, this is spring of 2020. Support for College Algebra, entire class into the notes. And I actually want to make a new folder there. Let me go ahead and make that new folder really quickly. I think I can do it. Let me see. Because I know now is the best time for me to do this stuff. If I procrastinate, this, notes, and I just want to do a new folder. Let me see. Handwritten notes. Save. Okay, cool. All right, so now if we go back, I want to share, send it to Box. This one, support, entire class into the notes, handwritten notes, export there. Oh, that's fine. Okay. Oh, one other thing. Daggone it. Paper. Take that off. Okay. Box. Handwritten notes. Shyster. I'll fix that later. Okay. Send it to Box. All right. So when this bar finishes loading, you'll actually have a copy of all the work that you saw me writing on this app. you'll get a copy of it. And so to access it, you would actually access. So I'm going to go ahead and switch over. So if we go to our Moodle page, which is here. So again, to access this information, you go to your Moodle page. Ooh, if you're frozen, I'm going to let it go. Okay, it is frozen, so I'm not going to worry about it right this second. But there's a box link at the top of our Moodle page. Okay, so when that bar finishes loading, you'll get a copy of all the work that you saw us do. And so on that note, we will end the session here. I'm available, so you call my office phone, email me. You got it. You have to be proactive. If you sit by and just fall by the wayside, that's going to be it. I mean, it's like, nobody's going to be mad at you, but you have to take an active stance in your experience. Okay, so we're going to end this session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.